This is the part 3 video of logarithmic equations for lesson 8.3, where we focus solely on solving. And I probably shouldn't say the word solely. I think we should look at it as a culmination of what we've done so far, because we're going to go back and refer to everything from part 1, where we learned about converting and evaluating. In part 2, we looked at properties of logarithms on it and how do we merge them together and how do we set up for equality. Is part 3 is a culmination of all those together. So we're going to kind of do the stuff that we did up here that we ended part 2 with. We're going to actually finish the problems. So we're going to apply the properties of logs and we're going to solve on them. And we're going to kind of take our time. We're going to figure out what we have. So when I look at a problem, I like to first kind of look at what structure is being given to me. Do I see any plus signs or minus signs outside of the logarithms? And I don't. They're not there. So that's good. That means I'm not dealing with the property of logarithm with addition or subtraction. I then have to take a look at, well, how many logs am I given? Do I have a log on one side or do I have a log on two sides? So I really do like to look at what's the structure first on it. And that's what we focus on in part 2 video. And so if I look at this one, log base 4 of 2x plus 11 equals log base 4 of 5x minus 4, I have logs on both sides. So my first step is going to be to cross out the logs. And I say that's my first step because we already looked at there's no plus signs or no minus signs. So it already says log equals a log. And when it says that, we can cross out the logs. And I'm left with 2x plus 11 equals 5x minus 4. Now that's a nice one to solve. So I would subtract the 2x. That would give me 3x minus 4. I would add the 4. 3x equals 15. X is 5. Now before I box it, and before I say, sweet, I'm done, I'm going to go back to this part. You cannot take the log of a negative expression. And you cannot take the log of 0 or a negative number. And the base cannot be those. So I always want to plug in my number into the parentheses. And just the parentheses here. And I want to check, do I get a positive expression on it? I do 2 times 5 plus 11. I am going to, again, I'll put it off the side, 21. That's positive. That's good. I can take the log of a positive. I do 5 times 5 minus 4. I get 21. Notice those are equal. Boom, they're both positive. I like it. I just check it. And we're going to kind of see a problem why it's important we check that. So just check your answer and make sure you get positive numbers in the parentheses when you plug them in for it. So if I look at number 2, I look at this, I do see logs on all sides. I see one side, I mean, this is a nice side right here. It's all by itself. But if I look on the other side, I see there's too many logs. I mean, I can't just keep them there. I have to have the goal of merging them together. I want both sides to say log, in this case, if I look at it, log equals log on it. But the problem is I have too many on the left side, so I have to think about it for a minute. I'm, in this case, adding for it. I am adding 2 logs. I need to merge those together. And so we looked at, well, when you're adding 2 logs, that's like adding powers. So I'm going to merge by multiplication. And so I'm going to take my x, and I'm going to take my x plus 1, and I am going to multiply those together. That allows me to merge. So when I see a plus sign, I see a minus sign, I have to merge first before I start solving. Now I go to the solving part. I look at my structure. Okay, if I look at my structure, do I have logs on one side or do I have logs on both sides? And in this case, I have logs on both sides. And so when logs are on both sides, you can cross out the logs. So ba-boom, ba-boom, gone, and I'm gonna write it down, x times x plus 1 equals 6. Now this one's a little trickier because when I do the distributing, I'm gonna get x squared plus x equals 6. And this is a quadratic. And to solve a quadratic, we want to set it equal to 0. And so in that case, I would subtract the 6. So x squared plus x minus 6 equals 0. And to solve it from there, we would do factoring. So I'm going to set up my problem. Let's see, I am looking for numbers that multiply to give me negative 6x squared, and they add to give me a 1x. And so that'd be a 3x and a negative 2x. So I'll put the 3x here, negative 2x here, and that would be, see, top row has a GCF of an x. So I have x, I get x times x is x squared, x times negative 2 is negative 2x, and then 3 times negative 2 is negative 6. So I have x plus 3 times x minus 2 as my factors, that equals 0. And so if I solve both of those, I get x equals negative 3 from x plus 3 and x equals 2 from x minus 2. Do not box the circle yet. You want to check your answers. So let's check. And you just plug them into the expressions. So I'm going to plug them in, and I'll use purple up here. I'll plug in negative 3. So I plug in negative 3, I get a negative 3 here. And that's a warning. I can't take the log of a negative number. I can't do log base 11 of negative 3. And so that means this does not work. When you plug it in, you get a negative number, and you cannot take the log of a negative. So that one's done. And by the way, it only has to fail once. I plug in negative 3 there, I get negative 3, it doesn't work. If I plug in negative 3 here, I also get negative 2. That doesn't work. So it fails in both places, but as long as it fails once, it's not going to be a solution. So let's plug in the next one with a 2. Let's plug in 2. 2. Perfect. Positive. 2 plus 1 is 3. Now I want you to kind of think about this for a minute. This is really interesting. If I have log base 11 of 2 plus log base 11 of 3, what do we say we do? When we add logs, we merge by multiplying these together. And doesn't that give us 6? So we actually get 2 statements. We go through and do it. So I like this one. This one is acceptable because it got me positives when I plugged in. So that's number 2. Primarily this negative expression thing, you're going to want to be careful with problems primarily when you're factoring. Because when you're creating multiple solutions, there's a good chance that one of them is going to create a negative number. And most of the time when you plug in a negative number, you'll end up with a negative number. So let's look at number 3. I see this, and like which side looks good? And that right side to me looks awesome because it is one log all by itself. It's simple. That left side has too much there for me. It is too many logs. So I need to look at how do I merge them together into one single logarithm. And so I take a look at what's being done. And it looks like I am subtracting my logs. And when you are subtracting logs, you merge by dividing. So I am going to make it look nice on the left side. I am going to merge it into a single logarithm, just like the right side. But I'm going to do it by taking my 4x plus 5, by taking my 3 minus 2x, and I am going to divide them. I'm just going to write it like a fraction. There. Now that I use my properties of exponents to merge the logs together, I can look at which structure is given to me. Do I have a log equal to a log, or do I have a log equal to a number? And in this case, I have a log equal to a log, which means I can cross out my logs. So boom, boom, gone. Now I'm going to do something really interesting here. When I write down my 4x plus 5, I see it's a fraction over 3 minus 2x. But when I write down that right side, it's just a 2. Well, I'm going to write 2 as 2 over 1. And that's going to allow me to cross multiply. And so I will have anything times 1 is just by itself. So I'll have 4x plus 5 equals 2 times the 3 minus 2x. Now I can just solve this. Keep that left side, 4x plus 5. Distribute the 2, 6 minus 4x. See, I would add that 4x, and then I would subtract the 5. So I get 8x equals 1. So x equals 1/8. And I'm just going to quickly check. I know that is a decimal, but however, if I plug in 1/8 into here, I mean, I have a positive number, 4 times 1/8 plus 5. I know I'm going to have a positive on the left side. 3 minus 2 times 1/8, they're going to be a positive. That's good. So I just solve, but it's this thought process. Merge them first. Get it so it says a log all by itself, and then figure out, do I cross out or do I go to exponential form? Number 4, when I take a look at this one, in this case, I like the left side because that left side is all by itself. There's no plus sign, there's no minus sign, and particularly, there is no coefficient on the left side, but there is one on the right side. So that 2/3 really bothers me. And I can't have that. I have to have it look like this. I have to have it say log base 7, no plus signs, no minus signs, no coefficients. That's what it needs to say. So I have to take that 2/3 and I need to bring it up. And so I'm going to take that 2/3 and I'm going to make it the exponent for that 8. Now that looks nice. And I look at it, so I merged by creating, I'll write this down, I merged by creating an exponent. Or you could say power if you want to think of like the power rule. I merged by creating a power. Now I look at, well, what solving structure do I have? Do I have log equals log, or do I have log equal a number? And in this case, it's log equals log. Man, those are nice. Because when it's log equals log, I can cross out my logs. And so boom, boom, gone. So I have n equals 8 to the 2/3. Now you could pull out your calculator, and if you're going to type in your calculator, you want to make sure you put that 2/3 in a parentheses. That's the only way to do it. Or realize we did rational exponents before. Thirds means third root, so I'm going to take the third root of 8, and then I'm going to square it. So third root of 8 is 2, 2 squared is 4, so n equals 4. Done. Even if you type that in the calculator, make sure you have the parentheses there, it'll tell you 4, and it's the right answer for it. So in this case, you had your coefficient there. We've seen examples of product rule, of division rule, and of power rule. Product, quotient, and power. Let's go to number 5. Now, if I look at number 5, right off the bat, this looks a little bit different. I'm not going to tell you why. But if I ask which side is nice and which side looks like it needs to be merged together, I mean, hopefully you're going to say the right side is nice because that's just the number 3. And hopefully you're going to tell me that the left side doesn't look as good because there's this plus sign there, and we can't have that. The log base 2 has to be all by itself. No plus signs, no minus signs, no coefficients. And so I have to ask myself, how do I merge together when I have a plus sign? And I merge by multiplication when I have a plus sign. So I am going to take my x, and I'm going to take my 4, and I am going to multiply them together and say 4x. Perfect. Now I can look at my solving structure. In this case, do I have a log on both sides? So does it say log equals log? Or does it say log equals a number, equals a value? And here's where it's different. This problem says log equals a value. That's why you can't just cross out the logs right away. You have to stop, merge first, look at what you're given, and then focus on which structure you have. And when it's log equals a value, what we do is we convert to exponential form. And so I'll write down, let's get rid of the red. I'll write down log, we'll do the color coding we've been using, base B, I believe I used green, N equals, this was a darker green for some reason, P. That is the structure of a logarithm. And when we convert to exponential form, we say your base attaches to that power. So I'm going to have my base to my power, and it should equal that number. That was part one. We learned how to solve these problems in part one, right here. Look at this, 1 through 5, technically 1 through 6. And we solved these. Log equals, we just didn't know what that number was, but we converted every time. So solving number 5 is really just like the first problems we did. When you have one log, you're trying to evaluate it. Well, that gives me some more confidence. So now my base is 2, my power is 3. So I'm going to say, I'll color code it, 2 cubed equals 4x. I can solve that. 2 cubed is 8. 8 equals 4x. X equals 2. If I plug it in, get a positive number. Boom, boom, boom. We are set. Perfect. And I did this on purpose. That this was the first time in this whole video where we had log equals a value. And I say that because we're still going to do the last one. But notice, cross out logs, cross out logs, cross out logs, cross out. We did 4 in a row where we cross out logs. But then all of a sudden that one couldn't do it. Don't just cross out logs because I'm going to cross out logs. Always take a second and analyze the structure that you are given. That's why we did part 2. We took one lesson and just focused on analyzation, reading the problems on it, so we can think for a moment on what solving technique we're going to use. All right, last one. And this one's interesting because when I see this, it's a little intimidating. And it's intimidating for a few reasons. It's intimidating because I have these coefficients here. I have this 2 and I have this 1/4. The right side's not intimidating at all. I mean, equals log base 6 of x. Not intimidating. The left side is, and it's because of those coefficients, but those coefficients don't mean anything because I can merge by creating powers with those coefficients. By creating exponents, this 2 up here. And so really it would say log base 6 of 4, but now it's going to be 4 squared. Minus, let's make sure we're doing the color coding. So we got boom, minus that 1/4 is going to come up with the exponent to that 16. So minus log base 6 of 16 to the 1/4. So got rid of those coefficients, they're bothering me, but there's still something else bothering me, and it's this minus sign. There's still too much on this left-hand side. I mean, that right-hand side, beautiful, equals log base 6 of x. It's so simple. The left-hand side has that minus sign, and so I think about when I'm subtracting logs, I have to merge by dividing. So I'm going to create one single log base 6 because that's so nice. I'm going to take my terms. I'm going to take that 4 squared, and I'm going to take that 16 to the 1/4, and I'm going to divide them. Personally, I mean 4 squared, I'm going to at least do this. 4 squared is 16. So I'm going to rewrite this. Log base 6 of 16. 16 to the 1/4. Now, wait a minute. We dealt with rational exponents. That means 4th root of 16, which is 2. Oh man, I could still simplify this. I might as well just keep doing that. Log base 6, 16 divided by 2 is 8, equals log base 6 of x. Now I simplify. So now I look at this. I got my log on the left side, I have my log on the right side. Well, I have a log on both sides. So I can cross out my logs. Boom, boom. I'm left with x equals 8. And by the way, if I were to plug it in and check, it does work. There's no issues. So this one's really, I say long, but if you look at the long part is right here. And all that is up, up, that's really the longest part. Now I want to take one moment and go up to the beginning of this because I just jumped right into it with powers and then dividing. But the question is, could I have done the division first and the powers next? And you could. There's a reason why I did my exponents first and then I did my division. And the reason why is, think about it, order of operations. You do your exponents first, then you deal with multiplication or division on it. So when you have multiple merging techniques there, follow the order of operations. That's what problem 6 is meant to go over. So this is part 3 of the video. It's really taking this idea of part 2 with merging them together and analyzing, solving, and actually finishing the job. Some of the harder ones are going to be the ones that involve factoring. So be careful if you're looking at a quadratic. And when you have a log equals a value, those are the ones that people, for the most part, really get messed up. And the reason why is because you get so used to cross out logs, cross out logs, cross out logs, is you kind of stop doing that step. Pause. Take a moment to read the problem and always do that step for it. So hopefully this makes sense. If you have any questions, please reach out.